Hi and welcome back to the Property and Structure of Matter, and today we're looking at the Schrodinger model. Now, the biggest difference between Schrodinger model and the Bohr model is the way the electrons are considered. So Bohr viewed them as small particles that revolved around the nucleus in circular orbits. Schrodinger viewed them kind of as having wave-like properties, so halfway between a wave, halfway between a particle. And he also said that the electrons occupy a 3D space around the nucleus called an orbital. So he found the following. He found that there are major energy levels called shells. Within those shells, there are separate energy levels called subshells, and he named these S, P, D, and F subshells. Now, within those subshells, he said that each subshell can only hold a certain number of electrons. Now, within those, we're going to look at those different things. So he worked out that the different energy levels for the electrons corresponded to the different shapes and sizes for each of the space of the electrons occupy, and he called them orbitals. So let's have a look at what orbitals are. So an orbital is this area of space surrounding our nucleus, and one or two electrons can move in this space. So our first one we call an S orbital, so it's a spherical shape there, and in each one of these orbitals a maximum of 2 electrons can exist. So in our first shell we only have a 1s, so if you think of our first row of our period on the periodic table, remembering each period corresponds to how many shells it has. So period 1 only has 1 electron shell and it has a 1s orbital. So 2 electrons can fit in that region of space. So the first shell only has 2 electrons. We then move to the second shell, and in the second shell, those electrons will fill first the first shell, 1s orbital, and now it starts filling the 2s orbital. Again, only 2 electrons can fit in that space. When we get to the 3s, 3 electrons can fit that space, and 2 electrons can fit that third shell. But let's have a look at the second shell. The second type of energy level consists of our orbitals there. Our second energy shell can fit 8 electrons. So it has a 1s, first of all, in the first shell. In the next one, it has a 2s. So it fits 2 electrons in that s orbital. There's a remaining 6 electrons that can fit there because we know there's a maximum of 8. So in that case, we have what is called 3p orbitals. This is a 3D structure. So we have got a pear-like shape up and this way, a pear-like shape this way, and a pear-like shape going backwards, so some depth in a 3D shape. Now remember, every orbital can only fit 2 electrons. In this orbital here, 2 electrons can fit, 1 here, 1 here. This is the second orbital, 2 can fit here, 1 here and 1 here. And in the third, 1 electron here and 1 electron here. So for our 3p orbitals, we will have 6 electrons going across there. Now, with our third energy level, these are far more complex. Their shapes are much more difficult to describe. By all means, research and have a look what they look like, but we don't need to worry about that. But what we do know is it has 9 orbitals in this third energy level. So again, the 3s, so the sphere, it'll have 3 of the p orbitals, again, similar to what we just saw before, but now it's got 5 d orbitals as well. So a lot more complex. And then when we go into the next one, we can even have up to 7 f orbitals. So that's quite tricky, with each orbital holding a maximum of 2 electrons. So how do we feel this? And this might help explain some of that up and down movement that we saw when we were looking at electron configuration. This is how the main energy levels are made up. So if we look at 1s over this side here, you can see the 1s is of lower energy, E being energy on the side. Then we go and we fill up our 2s. So it's again lower energy. We fill up our 2p. But when we actually compare the energy here, we look at the 3s. Again, we fill our 2 electrons in there. Our 3p, we fill in our 3. But we can actually see that the 4s orbital there is lower in energy than actually the 3d, which is why we start filling the 4th shell of potassium and calcium rather than filling the 3d orbital. So it's lower in energy. So we're filling on the basis of energy there. So another way of representing this, again, each one of these orbitals can fit only 2 electrons. So we fill our 1s, we fill our 2s, we put the 2 in each of the p's, then we put 2 in the s, fill the 3p, then the 4s, and we keep moving up. But a way I like to use is what I call my Christmas tree, and I follow the path of the arrows. I fill the 1s, the 2s, the 2p, the 3s, and so forth. And these are really easy to draw. If you put a row down this side here, 1s, 2s, 3s, 4s, 5s, up to 7, and then we drop 1. So now always the 2's line up, 2, 2, 3, S, D, then we're getting S, P, D, F. But we're dropping 1 down each time. It's very easy to draw and it's a lot easier to follow. So let's have a look at a couple of examples here. I've put the table on the right hand side to help you have a go at each of these using the diagram on the right hand side. Have a look at how you might draw the orbital notation. So we're going to call that orbital notation, different to electron configuration, for each of these elements here. Pause the video, have a go, and we'll come back and check your answers. See you soon. So how did you go? If you had any trouble with any of these, we'll talk about it in class tomorrow. See you then.